Hi everybody, welcome back to videos. This is Unit 6, Lesson 1, and today we're going to talk about why bonds form, what a chemical bond is, and what happens to energy when bonds form. So you should have your Unit 6 notes in front of you, and we're going to fill in the first page of those Unit 6 notes. So, first we have to talk about what the heck a bond is. And when I was younger, I used to think a bond was an actual physical structure, like a toothpick, that held these atoms or balls together. But in actuality, it isn't. A bond is simply just a force of attraction. Now, you'll have to write this whole thing, right? A force of attraction that holds atoms together. It holds atoms together and allows them to function as molecules. So when atoms bond, they leave their individual identities at home, they become a molecule, and they assume that identity of that new molecule. They are no longer an individual atom. They are a whole molecule, and they have different properties as a molecule than they did as an atom. This is a strong force. This force is relatively strong. It takes a lot of energy to break it because, let's face it, atoms are happier when they're bonded than when they're separate. So why do bonds even form? Bonds formed because atoms need to have a full outer shell of electrons. This will make them stable. And, of course, happy. Okay, so the whole point of forming a bond is to become happy, to complete your outer shell. And if you do that, then the element will be happy and stable. Usually, unless you're a transition metal, only the valence electrons, the outermost electrons, are involved in bonding. Remember, valence are the outermost electrons. Are involved in bonding. So elements will form bonds in order to have that full outer shell, which we call a noble gas configuration. So they will bond in order to achieve a noble gas electron configuration, which is the full outer shell, right? Keep in mind, the first shell is full with 2 electrons, okay? So if you're hydrogen and your configuration is 1, you only have 1 shell, hydrogen will need 1 more to be full. So it will need to gain or share 1 to be stable, because the first shell is always full with 1. Every other shell, however, is happy or full with 8. Okay? So if you are sodium, okay, and your configuration is 2, 8, 1, okay, then your outermost shell is your third shell, right? 1, 2, 3. So sodium would need to gain or share 7 to be stable. But sodium is a metal. And metals are losers, right? So instead of gaining or sharing 7, it will lose 1. And then its next shell, which is the second shell, is full with 8. If it loses 1, then it's happy. And of course, if you lose 1 electron, then you take a positive charge and you'll be happy. So metals will lose to look like the noble gas that comes before them, and nonmetals will gain to look like the noble gas that comes after them, or share. It's very important. We'll be talking more about that later. Okay? So that's what a bond is. It's just a force of attraction. Usually it's between oppositely charged particles. We'll talk about how that force forms in our next little section here. What we need to talk about, though, today is what happens to energy when bonds are formed. Okay? So energy is released when chemical bonds are formed. So when A, right, and B get together to make a molecule, we'll call it AB, they give off energy. And that energy could be released as light or heat or sound or whatever. But when bonds are formed, energy is released. And there's still some energy left, and the energy that's left is stored in the bond as potential energy. Okay? The energy that's released when a bond is formed is equivalent to the energy that you would need to break it. Okay? So a part, right, they're unstable when you put them together. So if you have A, B now together as a molecule and you want to break them apart, you have to put energy in because they're happy now, right? So you must put energy in to separate them. It takes energy to break bonds. Take and break bond. It takes energy to break bonds, and when bonds are formed, energy is released. And there's a relationship between how much energy you have to put in to break it and the stability of the bond or the strength of the bond. And it's a direct relationship, one you might expect. So, I think I have it here on the next page. The more energy you released when bonds are formed, the stronger and more stable the bond will be. Because that would really mean it's harder to break. That bond is harder to break. Okay? So what I'd like you to do for class tomorrow is at the very bottom of the first page of your notes, you have this table, okay? I'd like you to answer it. This was actually a Regents multiple choice question, and they wanted to know which bond was the most stable given the information in this data table. Okay? So take a minute and put a star or circle your answer, and we'll check that tomorrow when you come in. Have a great night, everybody. We'll see you in class on Wednesday tomorrow. Bye-bye.